Stream. Let's see.
Is how's university going?
It's alright. I think it's alright. Let me just start the overlay before I speak more because my brain cannot do multiple things. See, start that, and then I should be able to open that. So I think I should have the streamer overlay, and we should have everything going live on all of the platforms. Yes. Yeah, I mean, university is going all right. I mean, actually, it's going pretty good, to be honest. I think. Like, I haven't really been struggling in any kind of way, so, well, too much because all I do.
It's crazy. I'm hyped for the maths in university.
Let's see. Okay, Hans won't be joining. Let's call off the chats. Hello, Peppa. Yeah, no, it's just so like everything is actually quite fine except for the Charlie Kirk event. I think that happened. So that's the only thing that's kind of like sad.
Yeah.
Hello, Breeze.
Yeah, that's what you say.
So yeah, it has been.
Like, I think America is cooked.
Yeah, but it's like it has had a big oof. Like, I kind of feel a bit down these past few days, but I mean, kind of need to just move on, you know. I'm also talking with my sisters who also they loved him and used to be excited to watch his clips every morning, and then they woke up to that one morning and was like, shit. So. Let's see. Why is the stream overlay not doing its thing? People are sending messages in the chat, but nothing is happening. Hello, Chupak. Let's see why that's the case. I will just restart the overlay. Let's see what it does. Ah, look at that. That's not good. Okay, so it's probably just had a stroke the first time with this. That's why it's continue and continue. Okay, so you can now close this window. Okay, start. Oh, let's see. I think, did I get it? Is the overlay there? What the fuck happened to the sound? Where's the sound coming from? Wait, what? Is the sound coming from the wrong place? Wait, desktop audio. Wait, can you speak? Say something, T-Chef.
Yeah, hello.
Okay, good. Lukaku, good name too. Yeah. I think let's see, I don't know. Something happened to the music. Alright, but now everything is alright. I think, I hope, I believe, lol. Let's see. Yeah, so now it's connected to both the Twitch and YouTube. Okay, anyways. Just gonna read on the multiplayer stuff, so that's kind of the plan for now, just to get a better understanding of how multiplayer works. And we might have to smash it to fix it, or punch, yes. In the first article of this series, we explore the client-server model and an authoritative server and dumb clients that just send input to server and then render update the game state when the server sends it. A naive implementation of this scheme leads to the delay between user commands and the change on the screen. For example, the player presses the right arrow key and the character takes half a second before it starts moving. This is because the client input must first travel to the server must process the input and calculate a new game state. The update game state must reach the client. Yes.
Wait, Lucas, can you stream in Discord?
Oh, sorry, yes, I can do that. Let's see. Like so. Okay, I can't stay too long. I need to go back to database and algorithms. Oh, that's nice. I was supposed to study a bit of databases during the weekend, but I just ended up doing more math instead. But it's okay. I think anything is just bringing more home, right? Just doing more. Let's see, client action move right units new state, and then it takes 100 milliseconds. Yes, in a network environment such as the internet where delays can be 10 or hundreds of milliseconds, a game may... Damn, I'm still so fucking loud. Oh yeah, because I have... Oh, whatever. The game may feel unresponsive at best, or in worst case be completely unplayable. In this article we will find ways to minimize or even eliminate that problem. Client-side prediction. Even though there are some cheating players, most of the time the game server is processing valid requests from non-cheating clients and from cheating clients who are cheating and at that particular time. This means most of the input received will be valid and will update the game that state as expected. That is, if your character is at 10:10 and then the right arrow is pressed, it will be up at 11:10. You can... So it considers positive going up. Okay, well, I guess in a coordinate system. I was thinking of a pixel screen, so wait. We can use this to our advantage. If the game world is deterministic enough, that is, given a game state and a set of inputs, the result is completely predictable. We can send the input to the server and immediately process them on the client. That is, we predict that the game state will be after the server has processed the input. This eliminates the delay between receiving and input and rendering its effect. Furthermore, most of the time this prediction will be accurate, so there will not be any visible mismatch once the server does and send the update game state. Let's proceed. Let's suppose we have a 100 millisecond lag, and the animation of the character moving from one square to the next takes 100 milliseconds. Using the naive implementation, the whole action would take 200 milliseconds. Since the world is deterministic, we can assume the input sent to the server will be executed successfully. Under this assumption, the client can predict the state of the game world after the inputs are processed, and most of the time this will be correct. Instead of sending input and waiting for the new game state to start rendering, we can send the input and start rendering the outcome of that input as if they had succeeded. While we wait for the server to send a true game state, which more often than not will match the state calculated locally. Yes. Now there's absolutely no delay between player action and the result on the screen. While the server is still authoritative, if a hacked client would send an invalid input, it will render whatever it wants to on the screen, but it wouldn't affect the state of the server, which is what the other players see. Synchronization issues. In the example above, I chose the number carefully to make everything work fine. However, consider a slight modified scenario. Let's say we have a 250 millisecond lag to the server, and moving from square to the next takes 100 milliseconds. Let's say the player presses the right key 2 times in a row, trying to move 2 squares to the right. Using the technique so far, this is what will happen. Okay, move right. So we'll move back and forth. We run the intersecting problem. Run into the intersecting problem. T equals 250 milliseconds. When the new game state arrives, the predicted time state at the client is x equals 2, but the server says that the new game state is x equals 11. Because the server is authoritative, the client must move the character back to x11, but then the new server state arrives at 350, which says x equals 12, so the character jumps again, forward this time. From the point of view of the player, they press the right arrow twice, the character moved 2 squares to the right, stood there for 50 milliseconds, jumped 1 square to the left, stood there for 100 milliseconds, jumped 1 square to the right. This, of course, is unacceptable. This is what I would run into if I do right now what I was thinking of doing. It's a server reconciliation. The key to fix this problem is to realize that the client sees the game world in present time, but because of lag, it updates it gets from the server the actually a state of the game in the past. By the time the server sends updated game state, it hadn't processed all the commands sent by the client. This isn't a terribly difficult to work around though. First, the client adds the sequence numbers to each request. In our example, the first key presses request 1 and the second key presses request 2. Then when the server replies, it includes the sequence number of the last input processed. Wait. Client move right 1 unit, client move 1, and then here it says your P1 got up to 1, accepted it and reapplied input sent since result. Okay. So you keep track of the things that you send and then check if it's associated with your latest one. Okay, I mean that's good. Okay. Now at 250, the server says, based on what I've seen upon your request, first, your position is X because the server is authoritative. It says the character position at X11. Now let's assume the client keeps a copy of the request it sends to the server. Based on the new game state, it knows the server has already processed request 1. So they can discard that copy, but it also knows that the server still has to send back the result of processing request 2. So applying client-side prediction again, the client can calculate the present state of the game based on the last authoritative state sent by the server. Plus the input, the server hasn't proceeded yet. So at T250, the client gets X11 last processed request. It discards the copies of sent input to hashtag 1, but it retains a copy of hashtag 2 which hasn't been acknowledged by the server. It updates its internal game state with what the server sent, x equals 11, and then applies all the input still not seen by the server. In this case, input 2 moves to the right. The end result is x equals 12, which is correct. Counting with our example at t equals 350, a new game state arrives from the server. This time it says x equals 12. Last process request equals hashtag 2. At this point, the client discards all input up to hashtag 2 and updates the state with x equals 12. There's no unprocessed input replay, so processing ends there with the correct result. Odds and ends. The example discussed above implies movement, but the same principle can be applied to almost anything else. For example, in a turn-based combat game, when a player attacks another character, you can show blood and a number representing the damage done, but you shouldn't actually update the health of the character until the server says so. Because of the complexities of game state, which isn't always easily reversible, you may want to avoid killing a character until the server says so. Even if its health dropped below 0 in the client game state, what if the other character used first aid kit just before receiving your deadly attack? The server hasn't told you yet. This brings us to an interesting point. Even if the world is completely deterministic and no clients cheat at all, it's still possible that the state predicted by the client and the state sent by the server don't match after reconciliation. The scenario is impossible as described above with a single player, but it's easy to run into when several players are connected to the server at once. This will be a topic of the next article. Oh, that's really why multiplayer allows for some funny ass, glitches and shit, like Minecraft, dupe glitches or whatnot, because everything else is just well, it's kind of hard because you can get to a point where you're like, the server knows of a few things, and let's say then you leave and you join back in, and then you send a request that this is actually my information right now, and then the server's like, okay. I mean, like, let's say Minecraft and you have like some diamond sword or something whatnot, and then you drop the sword, and then you join back in, and like you leave while dropping it. So the server has acknowledged your drop, but not acknowledged to update your inventory. So when you join back in, you would still have your sword in your inventory, you know. And then it's like when you connect this, like, yeah, this is my information. The server's like, yeah, all right. So you would have 2 diamond swords now.
Yeah, we trust you.
We trust you. I don't know really, but it's kind of like everything has to be tracked. It's well, I mean, if you if you process every input, every action through the server, everything should be deterministic, and you shouldn't be able to do anything weird, right? Everything should be able to have some sort of logical based action that just makes sense. And so the client should only be responsible for input, action handling, and then drawing, animating. Of course, they will keep a state of the game, which also kind of needs... Fuck, but you don't want to do calculation? That's kind of weird, like, because you want to do calculations on the server as well for the copy of the game to validate stuff, but then again, you also don't... It's so weird. Like, I'm trying to think just how should one separate this information up? Like, should there be just the game that runs on the server? Should that actually be the game? But then how do you send the necessary information? That's so weird, you know, like how what? Let's see, summary. Did I read that when using an authoritative server, you need to give the player you need to give the player the illusion of responsiveness. While you wait for the server to actually process your input. To do this, the client simulates the result of the input. When the updated server state arrives, the predicted client state is recomputed from the updated state, and the inputs the client sent, but the server hasn't acknowledged yet. What? Okay. How many? I should probably have read how many there is chapters in this thing. I cannot know. Well, that's funny. Oh wait, this is live demo is the last one. Ah, okay, so it's okay, it's not much, but okay. Okay, entity interpolation. In the first article of the series, we introduced the concept of an authoritative server and its usefulness to prevent client cheats. However, using this technique naively can lead to potential showstopper issues regarding playability and responsiveness. In the second article, we proposed a client-side prediction as a way to overcome these limitations. The net result of these 2 articles is a set of a concept and techniques that allows a player to control an in-game character in a way that feels exactly like a single-player game, even when connected to an authoritative server through an internet connection with transmission delays. In this article, we explore consequences of having other players control the character connected to the same server. Server time step. In the previous article, the behavior of the server we described was pretty simple. It read client input, update the game state, and sent it back to the client. When more than one client is connected, though, the main server loop is somewhat different. In scenarios, several clients may be sending inputs simultaneously, and at fast pace, as fast as player can issue commands, be it pressing arrow keys, moving the mouse, or clicking the screen. Updating the game world every time input are received from each client, and then broadcasting the game state would consume too much CPU and bandwidth. A better approach is to queue the client input as they are received, without any processing. Instead, the world is updated periodically at low frequency, for example 10 times per second. The delay between every update, 100 milliseconds in this case, is called the time step. In every update loop iteration, all the processed client input is applied, possibly in smaller time increments than the time step, to make physics more predictable. Wait, let's go. Wait. Okay, and the new game state is broadcasted to the clients. In summary, the game world updates independent of the presence and amount of client input at predictable rate. Dealing with low frequency updates. From the point of view of a client, this approach works as smoothly as before. Client-side prediction works independently of the update delay. So it's clearly also works under predictable. If relatively infrequent state updates, however, since the game state is broadcast at a low frequency, continuing with the example every 100 milliseconds, the client has a very sparse information about the other entities that may be moving through the world. A first implementation would update the position of the other characters when it receives a state update. This immediately leads to very choppy movement that is discrete jumps every 100 milliseconds instead of smooth movement. I guess yeah, that would be quite a sudden jump. Well, okay, yeah, I see. Depending on the type of game you're developing, there are many ways to deal with this. In general, the more predictable your game entities are, the easier it is to get it right. Well, we have quite predictable game entities. Dead rocking. Suppose you're making a car racing game. A car that goes really fast is pretty predictable. For example, if it's running 100 meters... If a car is running 100 meters per second, bro, my car is running.
The car's going fast.
Yeah. You know, I just imagine like a car with wheels going like... Boop, boop, boop. Not even spinning wheels, just walking with them wheels. The second light, it will be roughly 100 meters ahead of where it started. Yeah, why roughly? During the second, the car could have accelerated or decelerated a bit, or turned to the right or to the left a bit. The key word here is a bit. The maneuverability of a car is such that at high speed, its position at any point in the time is highly dependent on its previous position. Speed and direction, regardless of what the player actually does. In other words, a racing car can't do one-handed turn instantly. How does this work with server that sends updates every 100 milliseconds? The client receives authoritative speed and heading for every competing car. For the next 100 milliseconds, it won't receive any new information, but it still needs to show them running. The simple thing to do is to assume the car heading and acceleration will remain constant during that 100 millisecond and run the car physics locally with those parameters. Then 100 milliseconds later, when the server updates arrives, the car position is corrected. The correction can be big or relatively small depending on a lot of factors. If the player does keep the car on a straight line and doesn't change the car speed, the predicted position will be exactly like the corrected position. On the other hand, if the player crashes against something, the predicted position will be extremely wrong. Note that dead rocking can be applied to low speed situation, battleship for example. In fact, the term dead rocking has its origin in marine navigation. Huh. I mean, imagine making like World of what is it called, Warship kind of game. It would be pretty cool. I like World of Warships. But I suck at it. Entity interpolation. There are some situations where dead rocking can't be applied at all. In particular, all scenarios where a player direction and speed can change instantly. For example, in a 3D shooter, player usually runs stop and turn the corner at very high speeds, making dead rocking essentially useless as position and speed can no longer be predicted from previous data. You can just update player position when the server sends authoritative, I can't read that word apparently, data. You get players who teleport short distances every 100 milliseconds, making the game unplayable. What you do have is authoritative position data every 100 milliseconds. The trick is how to show the player what happened in between. The key to the solution is to show the other player in the past relative to the user's player. What does that mean? Key solution is to show the other players in the past relative to the user player. Say you receive a position at 1000, you already had received data at 900, so you know where the player was at 900 and 1000. So from 1100, you showed what the other player did from 900 to 1000. This way you're always showing the user actual movement data, except you're showing it 100 milliseconds late. Yeah. Wouldn't your player also have to be moving kind of like 100 milliseconds late? Server client. The server sends the update stuff. Client. Server updates and visual position and interpolation for past authoritative. Okay. The position data you use to interpolate from T900 to T1000 depends on the game. Interpolation usually works well enough. If it doesn't, you can have the server and send more detailed movement data with each update. For example, a sequence of straight segments followed by the player, or positions sampled every 10 milliseconds, which looks better when interpolated. You don't need to send 10 times more data, since you're sending the deltas for small movements. The format on the wire can be heavily optimized for this particular case. Note that using these techniques, every player sees slightly different rendering of the game world, because each player sees itself in the present but sees the other entities in the past. Even for a fast-paced game, however, seeing the other entities with 100 milliseconds isn't generally noticeable. I don't know. I have played League of Legends with 100 ms, and that's pretty bad. That's really bad. Well, I guess they did some prediction, I guess, so it's kind of hides it, but it's still noticeable. It's so bad. 60 is still doable, but as soon as you hit 80, that's when it starts to get bad. There are exceptions. Like, I don't know, Twitch has been freaking with me. It just says that I'm going live every 5 minutes. I swear. It says I'm being live for 11 minutes. I have been live for almost half an hour. That's crazy. Absolutely crazy. Where your target was 100 milliseconds ago. We'll deal with this in the next article. Summary. A client-server environment with an authoritative server, infrequent updates, and network delay, you must still give players the illusion of continuity and smooth movement. In part 2 of the series, they explored a way to show the user-controlled player's movement in real time using client-side prediction and server reconciliation. This ensures user input has an immediate effect on the local player, removing a delay that would render the game unplayable. Other entities are still a problem. However, in the article we explored 2 ways of dealing with them. The first one, dead rocking, applies to a certain kind of simulation where the entity's position can be acceptably estimated from previous entity data such as position, speed, and acceleration. This approach fails when these conditions aren't met. A second one, entity interpolation, doesn't predict future position at all. It uses only real entity data provided by the server, thus showing the other entities slightly delayed in time. The net effect is that the user's player is seen in the present that other entities are seen in the past. This usually creates an incredibly seamless experience. However, if nothing else is done, the illusion breaks down when and an event needs high spatial and temporal accuracy. So the shooting at a moving target, the position where client 2 renders client 1 doesn't match the server's nor client 1's position, so headshot becomes impossible. Since no game is complete without headshots, we will deal with this issue in the next article. The previous 3 articles explain the client-server game architecture, which can be summarized as follows. Server gets input from the clients with timestamps. Server processes input and updates world status. Server sends regular update snapshots to the client. Client sends input and simulates their effect locally. Client gets the world update and sync predicted state authoritative state interpolates known past states for the other entities. From a player point of view, this has 2 important consequences. Player sees himself in the present, player sees other entities in the past. This situation is generally fine, but it's quite problematic for every time and space sensitive events. For very time and space sensitive, okay. For example, shooting your enemy in the head. Like compensation. So you're aiming perfectly at the target head with your sniper rifle. You shoot, you can't miss. But you miss. Why does this happen? Because of the client-server architecture explained before. You were aiming at where the enemy's head was 100 milliseconds before you shot, not when you shot. In a way, it's like playing in a universe where the speed of light is really, really slow. You're aiming at the past position of your enemy, but they're long gone by the time you squeeze the trigger. Fortunately, there's relatively simple solution for this, which is also pleasant for most players most of the time, with the one exception discussed below. Here's how it works. When you shoot, client sends this event to the server with full information, the exact timestamp of your shot and the exact aim of the weapon. Here's this crucial step. Since the hello, is it can, or how do you pronounce that? When you consent it, full information accept. Okay. Here's the crucial. I don't know how to read that. Here's the crucial step. Since the server gets all the input with timestamps. Hello everyone. Okay. You're Kai. Okay, Kai. Hello, Kai. So the server gets all the input with timestamps, it can now authoritatively reconstruct the world at any instance in the past. In particular, it can reconstruct the world exactly as it looked like to any client at any point in time. This means that the server can know exactly what was on your weapon's sight at the instant you shot. It was the past position of your enemy's head, but the server knows it was the position of their head in your present. The server processes shot at that point in time and updates the client, okay? And everyone is happy. The server is happy because it's the server, it's always happy. You're happy because you were aiming at your enemy's head shot and got a reward headshot. The enemy may be the only one not entirely happy. If they were standing still when he got shot, it's their fault, right? If they're moving, wow, you're a really awesome sniper. But what if they were in the open position, you got behind a wall and then got shot a fraction of a second later when they thought they were safe? Well, that can happen. That's the trade-off you make, because you shoot at him in the past, they will still be shot up a few milliseconds after they got shot. It is somewhat unfair, but it's the most agreeable solution for everyone involved. It would be much worse to miss an unmissable shot. Conclusion. This ends my series on fast-paced multiplayer. This kind of thing is clearly tricky to get right, but with a clear conceptual understanding about what's going on, it's not exceedingly difficult. Although the audience of these articles were game developers, it found another group of interested readers, gamers. From a gamer point of view, it's also interesting to understand why some things happen the way they happen. Further, as clever as these techniques are, I can't claim any credit for them. These articles are just an easy understanding guide to some concepts I learned from other sources, including articles and source code and some experimentation. The most relevant articles about this topic are what every programmer needs to know about game networking, latency compensation methods in client serving, game protocol design and optimization. Those sounds good. Ah, amazing. For real, cannot. Nope. Let's see, what if I just... Hey, this has been renamed to something else, bruh.
Hello.
Hello.
I see your message, but I had like my hands occupied, so I had no possibility.
You don't need to. You don't need to explain. You don't need to explain. I think I have.
Yeah.
I think I have been on this page before. This one looks very familiar. Huh. Oh yeah, it was this I was reading over here. Yeah. Networking neutrality consider harmful. Networking physics, virtual reality. It's so interesting how complex multiplayer gets, you know?
Yeah, it's very complex. You press like that button, you know? It's like add multiplayer.
Yeah, right. That would be a nice button, but you think, you know, you have to first implement that button so you can press it, you know? That's the real problem.
Oh yeah, you do at import UI and then you do button.
Bruh. No. I dropped 50% of my frames. That's just sad.
Damn.
You don't say. Alright, now I can continue on with this. The code is pure JavaScript and is fully contained in this page. It's less than 500 lines of code, including a lot of comments, showing that once you really understand the concept, implementing them is relatively straightforward. Although it's not production quality code, you may use this code in your own application credits. It's appreciated, although not required. So... move. Ah. Oh, look at that. Okay. Okay. Okay, that's pretty cool. That's pretty cool. Okay, where was I? I was. It's gonna be a bit weird because I'm like, how is this one supposed to keep track of a state of the game? No, I don't even want it to keep track of full state of the game. What?
You could also use peer-to-peer.
Oh. But I'm still gonna, like, the thing is that I'm gonna run it as a database, the server, so that it would still have the same problems. Like the database.
You know, I think you are getting some scope creep.
No. I'm not. These are valid stuff. Because I'm not even trying to do anything too complicated. Okay, it's pretty complicated, but it's not that. Like I think it's still like pretty like doable things to deal with and should be dealt with. And especially if it's gonna be multiplayer, so yeah.
Sure.
Anyways, we got. Oh, okay. So this is where they spoke about the lerping. I was like, where the fuck is that lerping? But now this makes sense. If you're interested in learning more, check out this demo. Yes. So wait. It's that we're literally interpreting lerp between the position where the server says the entity is and where they're actually drawn. This is a common technique which provides for smoother movement. At this point, you have complication here because you can't convert. Fix this. Let's also create. Yo, hello.
Well.
Yo, Damon.
Well.
Technology.
What's happening?
We just finished reading the multiplayer article and now we're to continue on with the technology.
Nice.
Yeah, it's pretty cool. It's pretty cool.
Nice.
Nice. This just allows us to.
Yeah, in 10 minutes.
Yeah.
I just want to watch something while I eat, you know.
Okay. Eat. Enjoy food. I would like an apple. I think I might grab an apple. I think I'm gonna grab an apple. Wait, BRB. I need to wash it. I'm back.
Welcome.
With an apple. Why so many colors? Oh, it's color palette. Ah, it's an array of color. Okay, now I see. Okay. I realize I'm not reading out loud, but I'm eating an apple. All right.
No worries.
Okay. Okay, create the earlier from hook up the data. We are now prepared our Unity project so that you can hook up the data from our table, so the Unity game object, and to the Unity game objects and have them drawn on the screen. Add a couple of dictionaries at the top of the game memory class, which we'll use to hold on to the game objects we create for our scene. Add them to the 2 lines just below. Okay. Next, add some callbacks when the row is changed in the database. Modify the handle connect method as below. Okay. Here. Connect database on insert. On update. Okay, so here are all of the database stuff. Okay, now that makes sense. Add the following implementation of those callbacks. But is there on spawn food? On food. Okay, on food insert there. That's what I'm mostly interested. Okay, spawn food. Okay, but this insert food value. But how does it know the position? Is it the database food? Or what the fuck is this? Whatever. Game camera controller, let's see. Yes, I'm not concerned at the controller main camera. At this point you may need to regenerate your bindings for the following command. The last step is to call enter game reducer on the server passing username for our player, which will spawn a circle for our player. For the sake of simplicity, let's call the reducer from the handle subscription applied call back with the name 3 play. At this point, after publishing our module, we can press the play button to see the fruits of our labor. You should be able to see your player circle with username labeled surrounded by food. Okay. If you get an error running the generate command, make sure you have empty subfolder in Unity. Well, I don't. Okay. For me, the main concern is more in how do I make this thing actually respond to. I have to think like how the Unity has the game manager, which is kind of like this is. Need to think. Actually, need to think. Okay, let's say you have a client. Let's say you have a server. The server has this. This is server, and it has a state of the game. And let's just say this is the client. We're not even gonna think about player input right now. Here's the player client. There. And then the server is just going, you know what? Let's start spawning a bit of food here and here and here. Now this client over here needs to get aware of all of the food spawned over there. How does it get aware? Well, we can have it subscribed to the food spawn, which I think is still at best, but how does... Then I would have to expose that, and that's kind of like... I just like the update. I don't like to have anything else, and that. But then again, like this is okay. Wait, this is a bit bad demonstration of how it actually looks like. Let's do this. So there's the client, right? And then we have the platform, P, and then we have the actual game. The platform is communicating with this thing. right? And then this one is sending information to the game. Let's say, and then the game is sending information back regarding the screen. And this is the screen, this is the window, and then the platform renders the window. Now, how does it know? How does it get to the information that the data is stored here? This is the data, bruh. Let's do a D for data. Duh. Alright, and then, well, the server will also have to have its own kind of like data. It doesn't really display anything. This is a bad representation, I guess, but it's the data. This is the data, right? And this spawn information somehow needs to get into this thing, but the platform should not modify the data directly. No, it should not. So that means when this is being passed into game, it's when we need to. And how can I get that? Okay, food got spawned. I think there's only one solution. That's literally having this food spawn function, which the game then takes care of and be like, yep, food got spawned. When that thing gets called, and it can't say like where it got spawned. I guess that makes sense. So let's implement and expose it. So we can go in here. How do I? Let's see. Pub. Spawn. Food. And let's just take in a. We can take in a F32. X pause. Maybe we should do an I32. Y pause. I32. I'm not really concerned about any values or anything. Right now I'm just gonna I need to return an error. This is what I'm gonna be using to spawn the food. And what does that mean? Well, I need some way to keep track on it in state, because otherwise it doesn't make any freaking sense. But right now I'm not even keeping track of the game inside of the server, which I probably should do as well. Or do I? Do I even care about? I just check how close are you. Are you close enough to eat that food that you're trying to eat? If not, then that you're lying. I'm just gonna. We need a pub const. Let's call it food. Extern struct. And then we can just say y a32. I could maybe do I don't know, x and y. Why is this not happy? Variable must be initialized. Right. Alright, so now we will have a xy position. And let's just. They should actually just. But for now, I'm just gonna do it the most. I'm just gonna call it foods. I'm gonna say food. And it's gonna be a food array. Was it like this? I think it was like this. Let's say 128. Simple like that. Almost simple like that. So I want to start using it at the same time, but I cannot. Come on. Oh wait, I'm stupid. It's like this. Yeah. And then I'm just gonna say food count. This is not a good. It should be usize. But it's a solution that will work for now. Not too concerned about making it perfect. What? We can keep it like that, I think it's better. Anyways, so now we just say food. Yeah, I need a date. Fuck, I need a state. Okay, we'll take the state. And then I will just say state dot foods index by state dot food count is equal to dot y. Like so. And then we need to do a state dot food count plus plus. Yes. And that should be fine. Let's just go to check it out real quick.
I'm back.
Welcome back. How have you been? Have you been good? I hope you have been good because
No. They're the worst.
Current missing current. Why does it say missing current struct field foods? What?
You're not specifying the tie. No, you're right. For game state, I think this is because it's not like it wants you to specify the field because it doesn't have a default value.
How can I make this? I cannot say undefined, can I?
Yeah, you can do undefined.
But does this? Because when then I try to access, okay, as long as I don't try to read, but if I assign it and then read it, then it should be fine, right?
Yeah, that's fine. Yeah.
Okay, good. Let's see, what do we do here? Okay. I'm just gonna run it locally on this one, and then I will make it work on the on the server eventually, right? Spawn food, and you can. Oh yeah, but this one has a different. It takes in the state, and then it takes in an IPOS. And it's not an array, it's just I. Like so, I think that should be fine. Take it down here as well, boom. Remove that from there, and boom. And let's see, then we could go in here. Let's do a if I'm just gonna do it like this. If trailib dot is key down is key pressed. Yeah. Trailib key. Let's say P. If that is pressed, then we call spawn food. and we pass in the state, and we what the fuck do I take? I can just take the accumulated time. Modulo. I don't know, I will just take modulo 400. And let's multiply by 11. Right, oh shit. Right, fuck. Oh, I meant not. No, I want it to be that. Well, shit. I guess I have to cast it. Remaining division F3 and complaint signed. Oh, not used at mod. Okay, let's do that instead. Numerator, that's the accumulated time. And this. Let's see, why is this one not happy? Expected, I found. I could change it, but instead I would just do add as. I32. Well, that should be fine. Oh wait, it's not this thing that's the issue. It's the place that passed into. Like so. No, still not. Expected either found. Ah, bruh. In from float. Ah, that should be fine. Info must have a known result. So now we're here at as I32. Well, now you can tell me that you don't know, bruh. Use a functionality int from bruh. Yes, perfect. So now we just do the same thing, but for this. Oh my god, I hate Visual Studio Code. Let's see, but I want a slight difference with the multiply by 11 here. Can I get the... Yes, perfect. So if P is pressed, then it will spawn. As I have high hopes this will work. Right, it probably will work. The only thing that won't work is that I'm not even trying to render it. Let's see, we can do a function spawn cube or draw cube. And we'll take in, what do we care about? We care about the X position, so yeah. X pos I32, Y pos I32. Do we care about something else? I guess you could say color, which will be a I32 as well. So we can say I color like so. It will not return an error. It will just try to spawn it. We probably need access to. Do we need access to the state in this case? No, we only need access to the pixel buffer. I think I will pass that one first then, because that's like kind of like nothing else matters really if you don't have it. And then I will just take the logic from this. Oh, I could probably have set size, but for now I don't really care. Draw cube, pass in pixel. Oh no, just buffer. Box Y, and then we'll put. Wow, that's crazy. Well, this is the same as. Can I just go? No, because this one knows that we're talking about the pixel. Can I say pixel type dot int? Yes, I can do. Init opaque. Why? I think this should be fine. Let's just take it. And let's put one more and just remove that. And then here it will just say we'll take I32. What the fuck? Yo, what's up, pig? We'll put color, see what it is. And then here we will just replace this with xpos. That's a bit of a first. Wait, what? It's ypos. Ypos. Xpos. And I expected either found game pixel. Fuck you. It's the same. But how about your day? I had leg day. Lag day, I have pain. Lag day, that sounds pretty painful.
Yeah, it was lagging all day, you know.
Yeah, bro. My day is going alright. That should. I guess I will have to do a bitcast. Or unless if I change this color to be pixel, which is also fine. Because that's basic.
What are you trying to do?
Nothing. Forget about it.
Okay.
So,
oh no, you're not using my beautiful math library for 8 scholars?
No.
What? You don't like it?
Yes.
Oh, damn it. Well, I tried.
No, I haven't gotten to that point yet, alright?
Sure.
I'm telling you, bro.
Nah, man, you're lying.
Oh, I never lie, bro. I'm telling you.
Sure.
Yes, for real, on God.
Right.
Foods. Wait. So now I want to draw. Draw cube. That might be a bit misleading, but it should maybe be a draw square or something like that. But that's fine. You know, we cool. Actually, I could change these ones, but I already got. They are not floats. Whether it's not like somebody's gonna kill me for it, right?
Nah, they will.
Oh fuck. X, Y, and then I will just say pixel, and then we'll take this. Same thing. Boom. And we'll put it here. Boom. And let's change it to, let's keep it red for the moment being. And best case scenario, this will just run. Worst case scenario, it won't run. Let's start another terminal as well. So Zig Game -- watch. Let's see, it seems to be fine. Zig build run. No. Spawn food. Wrong buttons. I'm going to see. I need to get something to eat. Have a burger buns. Guess who eat good tonight? Damn, that sounds awesome. I just ate an apple. Let's see. Dynamic lived. Sick. Spawn food. Did I do a typo? Spawn. No, it seems to be. It takes the game state. And it takes a I32, I32, returns a void. But it did not find. That's why. Okay, now it compiled successfully. So, and then I can do this, and we should be fine. Okay, let's see if I press P. Nothing happens. Okay. Debug. Spawn. But it does say spawn. So I'm pretty sure that it gets through this thing at least. And it increments that. It says that this is. Let's see. I'm just gonna say any. Then I'm gonna say spawned. And then I'm gonna make a new line. And then I'm gonna say that we spawned in. Shit, I don't. Whatever. We can still access it quite easily by just saying that this state count -1, because otherwise we will have funny issues, right? And now if I press P, this is spawned, or it's just a spawned. It didn't take. What the fuck? So I probably did a typo down here. Let's see. No, spawn food. That one is. But why is it not updating my. No, what the fuck? Okay, let's see if I just do. Let's add it in the update. This is gonna be crazy, but it's fine. Oh, wow. That should not have happened though, I'm pretty sure about it. Let's see, it went to reloaded and then it went into here. Interesting. Let's try again. Press P once. Oh, okay, now it says P. So why did it not get hot reloaded? Anyways, there are definitely like cubes should be being spawned, but I ain't seeing shit, bro. Where are these cubes, bro? Bro. Okay, let's see. 4. I go through here. Let's just do a log num draw, and we're gonna say oopsie daisy d, then we're gonna say I, and then we're gonna go here and we're gonna do \n, and then Why aren't my shit stings working, bruh? Now it updated. It updated for this thing, but the STD, these things are not being. What the fuck? Let's see if I change the color to. We have red, green. Let's remove the green. Ah, it does update. Oh wait, but it's probably because it's not even getting into this thing. And why is that the case? Should be plus equal to 1. The new count. New count is 19, so it does keep track of the count. And then when we get in here, but here it's not saved, but we do take the reference. So unless I put it back to 0 at some point, this makes sense. But I don't. I take in the reference, I change the reference, and somehow I don't keep the. That's interesting. Okay, let's go back into here. Let's see what the fuck do I do. Spawn food. And then let's see. Oh, wait, did I? I'm passing in the wrong. I should be passing current state. Ah, okay. And that makes sense. Current state. Look at that. It's spawning food. Now we just need to make that this, I don't know, this is so cool that we can also go in here and we can change it to, let's say, let's make them blue, you know, let's remove the green and this and just make them blue. Boom, the food is blue. Crazy. I think it's pretty freaking crazy. And then we should be able to do this while it's multiplayer as well. And now that's gonna be super crazy. Yeah, I don't think this one will keep track of the spawning of food. What the it's actually, oh my god. That's so funny. Oh my god, that's so funny. Okay, that's pretty funny. Sure. There's a bit of weird funny stuff going on, but that's okay, that's okay. 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 I'm just gonna call that it for today. Tomorrow we will actually try to make this in the multiplayer thing somewhat work, so we can see things being called from the actual server to spawn in stuff, and I don't have to do it manually. But yeah, short stream, but small short progress stuff. Nobody watching and my Twitch is dying. Alright, bye bye.